If you're in the galleries, come on back out here. We're starting. Good evening. My name is Aska Hisa, and I am the Director of Learning and Engagement, and I welcome you to ICALA and to tonight's program, Drumbeat to Heartbeat. We're about to enjoy a unique combo. A lecture, a performance, and the presence of Milford graves through recordings provided by our featured guests, Dr. Julian Thayer and Scott Robinson. Tonight will be a presentation of scientific findings and the physiological impact of sonics and beats that preoccupied graves until the end of his life. We'll begin with a lecture by Dr. Thayer with a brief Q&A, followed by sound, music, and the legacy of Milford graves. We've provided some bio sheets on your chairs so that we didn't have to read their incredible careers and get started. But here are some highlights on this cool duo. Dr. Julian Thayer studied music composition at Berklee College of Music and received his Ph.D. from New York University in psychophysiology with a minor in quantitative methods. He is currently Distinguished University Professor of Psychological Sciences at the University of California, Irvine. And then I have to take a breath. And he is the Ohio Eminent Scholar Professor in Health Psychology Emeritus and Academy Professor at the Ohio State University. And there are many more roles he has played in distinguished universities. He has published over 450 research papers and is one of the world's leading experts on heart rate variability. He is on the editorial board of Music and Medicine, and Julian is also a critically acclaimed musician, which you'll enjoy soon. Multi-instrumentalist composer Scott Robinson has been a highly active presence on the New York-based creative music scene for nearly 40 years, appearing on some 275 CDs. And there are some of them right at the table over there that you can purchase tonight and support Scott. Some of them are recordings, rare recordings with Milford graves. Cash only, $20. Scott performs on both brass and reed instruments and is equally at home with the traditional and the adventurous. We hope to do both tonight and more. Scott resides on the East Coast, but we were really fortunate to reroute him to LA at the end of a tour in the region that actually ended just yesterday, right, with Maria Schneider's orchestra. So you're in for a treat tonight, and I don't know, where's Julian? We're gonna start with you. Oh, okay. Let's go.
Thank you, Oscar, for that kind introduction. So I won't take too much time, but I wanted to just talk about the importance of the work that Professor Graves was doing. And this goes back a long way, actually. And this is a quote from Charles Darwin's book, Expression of Emotion in Man and Animals. Some of you have probably heard of his book, Ascent of Man, but this is a very famous book of his as well. And he's talking about the work of the French physiologist Claude Bernard. And he says, Claude Bernard also repeatedly insists, and this deserves a special notice, that when the heart is affected, it reacts on the brain. And the state of the brain, again, reacts to the pneumogastric nerve on the heart, so that under any excitement, there'll be much mutual action and reaction between these, the two most important organs of the body. Now, I want you to imagine what we knew in the 1850s about the brain. What did we know about the heart, even? And this thing called the pneumogastric nerve, the vagus nerve, I mean, it's just mind-boggling to me what these people knew. And they made a specific prediction. Now, what's interesting about this is that Professor Graves discovered this as well. He was not trained as a scientist, but he knew all about this. And these are some pictures taken at his house of the professor and I discussing this topic. So as you can see, he's schooling me here. And he was clearly pleased with my answer. So I passed the professor's exam on that particular evening. But the vagus nerve is the longest nerve in the body. Vagus is derived from the same word as vagabond. It's the wanderer. And this nerve basically regulates every physiological system. And the professor knew this and was able to incorporate this into his thinking and into his playing. So when he was playing particular drum rhythms, he knew that these were natural rhythms that emanated from the body. And he could tell if a person had a heart arrhythmia by the type of rhythm that their heart produced. So he would tell me about, this particular rhythm, and then, well, this is this arrhythmia, and this is this arrhythmia. And he knew this. He had studied this. He was completely well-versed on this. We had very deep discussions about this physiology. So the key thing that we really connected on, and what he spent many years of his life studying, is something called heart rate variability. So briefly, when you inhale, your heart rate increases, and when you exhale, it decreases. This is called respiratory sinus arrhythmia. And contrary to what you might believe, your heartbeat is not regular. It shows variability. And the more variability in some ways, the better. So this is what the professor understood. So you guys all know what this kind of thing looks like. You see this on TV all the time. And so when I see these things on TV, I actually look at the monitors to see if those are realistic values or not. And most times they're not. People are dying and their heart rate is 120 beats per minute. No, it should be 0. That kind of thing. So what we're interested in is the timing between the heartbeats. Because they're not regular, that timing tells us how the vagus nerve is regulating the heart. So we can look at this in a number of different ways. Now, some of the things I'm showing you now, you'll actually see in the exhibit that Professor Graves provided. He has EKG charts that he has in his exhibit here. And you can see that heart rate variability is important. And this is just a simple graph of one participant, one person. And I just want to draw your attention to the red. It says HF. This is the vaguely mediated high-frequency heart rate variability. So this is sitting, and then when you stand up, it goes down. And when you sit back down, it goes back up. So this is just to make sure that blood is flowing to your brain so you don't faint. So this is, you can observe this in yourself. And like I said, the professor was well-versed in this. So this is a recording from a guy named Vaughan Macefield in Australia. And this is one of the first recordings in humans, direct recording of the vagus nerve activity. That's the top trace. So using a needle electrode in the side of the neck, he's able to measure the vagus nerve directly. This is one of the first examples of this in an awake human. And you can see then the RR interval trace. That's the heart rate variability going up and down. So heart rate variability is very important. We just published a paper recently. This predicts mortality. If your heart rate variability is too low, your risk of survival is less. And we published a clinical sort of cut point for this that can be used by physicians. But this is also important for things like music therapy. And again, one of the things that the professor was interested in was the connection between the heart and the brain as enunciated by Charles Darwin. So this is a study we did some years ago where we looked at the relationship between the brain connectivity in a couple of different regions and heart rate variability. And what we found was that activity in this area of the brain, which is important for our sense of safety, correlates the connectivity between that and an area called the amygdala, which is often called the fear circuit. It's kind of a threat detector. And you can see in both older individuals and younger individuals, the greater this connectivity, the greater their heart rate variability. So there's a lot of different kinds of therapies that are used for different types of disorders where they try to increase this connectivity. So a treatment for a borderline personality disorder in Germany, for example, they bring people into the scanner and they give them feedback to produce this change. So this is the professor's work here. Some of this, most of this is actually not in the exhibit. But what the professor did and what we will be using is he took his physiological signals and turned them into sound. And Scott will tell you a little bit about that momentarily. But there we go. That's his physiology. I'll play another one for you. This one actually has a little bit higher volume, so I'll have to be careful. Okay, so that's just a sampling of the work that the professor was doing and that we bonded over. And he provided us with some of those sounds, and we're going to play with those sounds tonight. So the professor will be with us. Scott, do you want to come up and say a couple of words about how you got these recordings?
Thank you very much for coming. Jules is a very old dear friend of mine. We were randomly assigned roommates at Music College in 1977. And believe it or not, we were even younger then than we are now. So it's been a near lifetime of experience with Jules. We're still dear friends, and he went into the science world, but he still plays the bass, and so we connect on all these different levels. And, you know, it was a kind of a natural fit to get him together with Milford Graves because, you know, I said, man, he's doing all this work. He's talking about heart rate variability. Jules is always filling my ear about that stuff, which is fascinating because we all think our heartbeat is supposed to go bang, 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 bang. And it doesn't actually do that. It's healthier to have some ebb and flow, isn't it? And that shows in the music, and Milford was a big believer in that. So I took Jules to see Milford Graves in Jamaica, Queens, and I introduced them. I said, this is the guy I've been telling you about. He's working in the, you know, on the science end, on the same kind of stuff that you're working on and all of this. And Milford looks at me, he goes, well, you're a little late. But that's okay, we'll get started, something like that. And so unfortunately, you know, we, together with the drummer Vernon Reid, we went to Milford Graves' house, and I had recorded with him. I had brought him out to my laboratory for what might be his last studio recording, which is over there on the table. along with some duo projects I did with Jules. And it was a great experience. In fact, I just saw the drums back here that were at my home. So, I was in a position to put the two of them together. And so then we had some meetings. We went out to Milford's house, and incredible experience. His gardens and all of his whole house is a piece of art. It's unbelievable. Everything's sculpted and stuff stuck on it all over the whole house. Everything about it and everything in it is amazing. And I think it was like his grandfather's house or something, right? So anyway, we were working toward a collaborative project where Jules would help Milford Graves get his scientific work published and recognized in the science community, where it kind of really wasn't that particularly recognized. He was a do-it-yourselfer. He did everything in his basement and stuff, and the science world was not really that hip to it. So the idea was for them to collaborate, get this work published, get it presented at scientific conferences and everything, and do it in conjunction with a music component that we were going to perform as a quartet. Well, Professor Graves became just more and more ill and was never able to perform with us, unfortunately. However, Jules did get his work presented in Boston at an event there, and I guess elsewhere. Something was published. And then when this exhibit was presented in Philadelphia, we were asked to perform. And their beginning, I think, was still the hope that perhaps Professor Graves would be able to come down and play, but he just was too ill to do it. And so in his stead, he sent me these recordings and gave us his blessing to use them in performance, and this was a great way for him to kind of be in the band, even though he wasn't able to be physically present. So then after that, of course, he left this world, and we're just left with great awe and gratitude for his work and his amazing drumming and his just unbelievable spirit and his scientific side and just all of it. Just an incredible, multifaceted genius on so many levels. So we're very honored. Thank you to Tanya and Aska for having us here at the ICA to do something along the lines of what we did in Philadelphia, bringing in the science and the music and all of that. And Professor Graves will be present in his own way. Thank you very much.
I guess I'd like to better understand exactly what's happening with the like frequency variability. So is it that the difference between one heart rate to like pulse between the next is like a numerical value, and they're like putting that into hertz?
Yes, and it's measured in milliseconds.
Okay. So when it changes faster than a millisecond, like how is the time part of it working when the pitch changes faster?
So with respect to the heartbeat, heartbeat itself, there are two major autonomic influences on the heart. So the autonomic nervous system kind of controls everything. And everyone knows about sort of the fight or flight response. So that's thought to be the sympathetic nervous system. But the sympathetic nervous system is actually slow, order of magnitude of seconds. So imagine, you're trying to cross this busy street and a car is coming towards you unexpectedly. If you depended on your sympathetic nervous system, you'd be dead. The parasympathetic nervous system, the vagus, is on the order of magnitude of milliseconds. So the millisecond resolution is about what we get when we're measuring the heart rate variability. So the quick increase in heart rate is due to a withdrawal of the vagal influence. So that's how your heart rate goes up, more or less to about 150 beats per minute. It's almost all due to what's called vagal withdrawal. So your sympathetic nervous system doesn't kick in until your heart rate gets above about 150 beats per minute. So it's a very interesting kind of phenomena. So you guys have all seen the show Mythbusters. You've heard about Mythbusters? So there was an episode of Mythbusters where they asked the question, can you dodge a bullet? Now, I'm from Brooklyn, so that's a really good skill to have. And if the conditions are right, and you have about 250 milliseconds, you can dodge a bullet. Yeah, incredible. And that's all the vagus. So, I hope that sort of addressed your question.
And so the vagus is connected to the parasympathetic system.
That's correct.
And that's also where they have slot machines and
Like the feedback to produce the change like you were. Well, first of all, thank you, because that was really next level. Yeah.
Thank you.
And transcendent. It was a vibe. You guys were like going places. So thank you. And you were talking about for borderline personality disorder, there's a feedback you can So I was interested. You were reading about the heart, deciphering, and how what's the relationship now? We're gonna talk back to it. We're gonna put something back into it.
Yeah.
To level the frequency or.
So the vagus nerve connects the heart and the brain, and the connection is bidirectional. And actually, it's very interesting. We've done a series of studies now, and we've been surprised by this. But the professor already knew this, which is really fascinating. That the heart actually is signaling the brain first. You would think that the brain is signaling the heart. It's actually the heart. These what are called vagal afferents go to the brain, and then shape the activity in the brain, which then feeds back down to the heart again. So in this biofeedback that they're doing in Germany for borderline personality disorder, they bring people into the scanner and they give them feedback when that connection between this part of the brain, the prefrontal cortex, and the amygdala, when that gets stronger, they are reinforced to do that again. So they get this feedback. It's called biofeedback, and of course the professor was doing this, decades ago. So by strengthening that connection, so this connection is important for recognizing safety. And one of the things that's interesting is that individuals exposed to sort of early childhood maltreatment, that connection is kind of broken. but it can be fixed, and that's what's really encouraging about some of the work that we've been doing.
How so?
So we've been doing a study here in Los Angeles, actually, at the University of Southern California, where we bring people into the laboratory and we have them breathe, slow breathing for like 5 weeks. And it increases that connection. And it actually increases the thickness of the frontal part of the brain. You know, it had been thought for a long time that you could not change the brain structure. But we can actually increase the thickness in that region that recognizes safety. We can do that in 5 weeks. So it's really kind of amazing. And this is because the signal going from the heart influences what's going on in the brain.
Right. Anybody else? Because I got a couple more. Okay. I'll share.
Yeah, thank you. This topic about the biofeedback and everything has me thinking about what connections there might be between biophysical things and neurological and cognitive things. It's an interest of mine, and it seems like there's probably, I mean, when you're talking about like signals in the locations in the brain and everything, it really has me thinking about this connection.
So one of the fascinating things that the professor was working on, and he published this with another group, was that sounds can influence the activity of cells. So he showed that sounds can shape cell function. Yeah, he published this with another group. Go to his website, you'll see this work. And there's a guy named Lee Bartel in Canada who's not, again, the scientists in some ways don't know about the professor's work. So this is what he has spent his career studying, how sounds can influence cell function. And he doesn't know about the professor's work.
What's his name?
Lee Bartel. He's in Canada, University of Toronto, I think. That's what I've been doing.
Oh my gosh, thank you. I was wondering about this. So like that connection between the prefrontal cortex and the amygdala, and thinking about medications like SSRIs versus like this sound connection that integrates like the whole body. It seems like to make those connections, like, can you speak to like the let's say like the SSRI kind of medications, and like in conversation with this more whole integration of like the stomach and the heart and the brain?
So there's a couple of things. One is that these connections are natural, spontaneous, but they can be cultivated, let's say, without drugs. But we published a paper some years ago where we looked at the effects of SSRI on this connection between the prefrontal cortex and the amygdala. And over the course of the 12-week treatment with a drug called sertraline, that connection increased. So by the end of the treatment, they looked like the healthy individuals. So that can actually happen. But the problem is that some of these SSRIs actually decrease heart rate variability. So they can actually sort of increase your risk for cardiovascular disease while helping you with depression. It's really kind of complicated. So I work in an area called behavioral medicine, so I'm not big on the drugs. but the drugs, have specific effects, and we've investigated those. Yeah.
Are you looking for volunteers for the studies?
Yes. Yes, actually.
Oh, sorry.
I'm sorry? So there are studies being done at the University of Southern California with a woman named Mara Mather. That's my colleague. And I don't know, Kai, are you looking for subjects too?
Not currently recruiting, but maybe. Sure.
Kai is at UCLA, and she's a researcher in this area as well. Yes.
Hi, thank you so much for both. This was incredible, the three of you. I have two questions, actually. One was if in your studies you have included studying cerebral spinal fluid rhythms. And also I was curious about the criteria for choosing the pitch and the timbre of the sounds, not only the rhythm, but also what was the criteria to choose the particular sounds? Were they tones or?
So those are two different questions.
Very different.
So the second one, are you referring to how the professor did this? So he has, and there's a chart he has in the exhibition, this software called LabVIEW. So it has actually the details of how he translated the physiology into particular sounds. Mm-hmm. So that's sort of a technique that he developed for himself that utilizes this. There are other people who do this kind of work as well, but the professor was one of the pioneers in this. Mm-hmm. Okay, so that was the second question. The first question refers to the cerebral spinal fluid, and with Mara Mather at USC, we are starting to look at that as well. And one of the things that we found in this first trial was that the levels of beta amyloid, which is thought to be associated with Alzheimer's disease, actually decreased after this 5-week treatment. So we actually just got another grant to study this in more detail. So we'll be studying it for the next 5 years. Now, Mara is a gerontologist, so there's often an older sample, but we always have a younger sample for comparison purposes. So you guys all probably most of you fit into the younger sample category.
Thank you so much.
Thank you.
Hi. This was really, really wonderful. Thank you so much for playing. I've gotten to ask you lots of science questions, but I'm going to take this opportunity to ask you a music question. I'm really curious about how you see the relationship between, heart rate variability, where the beat is fluctuating, versus so many forms of music where the beat is very rhythmic. And, I grew up playing piano with a metronome, and I wonder how, whether in performances like this, is there another way that you're tapping into a beat that's a little bit more organic, or how you see the relationship between those?
Absolutely. So I don't have any of my CDs over there, but we did a recording session in Oslo, Norway, some years ago. And it was 4 of us, Scott, myself, Klaus Sorensari on drums, and Jarmo Savolainen on piano. The 4 of us had never played together, but we went in the studio, and so from the first note it was magical. So we went back into the booth to hear the playback, and the comment from the non-scientists we were really breathing together. And that really stuck with me, because that's what we sort of entrained to when we were playing this. It felt like we were breathing together. So that's how we get there. And as you know, breathing is not regular. Synchronize. Yeah, exactly. Yeah, it's really amazing, right? These inanimate objects synchronizing.
That are on their own tempo and somehow.
That's right. So what's interesting is, and again, the professor intuitively knew all of this, which is that basically the universe is nothing but rhythm. That's string theory. That's the modern string theory. It's rhythm. It's vibration. That's all it is. So when we're playing, we're tapping into the rhythm of the universe. And the professor was acutely aware of this.
Well, it's two things, really. It's vibration and alto clarinet.
Yeah.
Yeah, thank you so much. I was just curious if you've ever played music or used the influence of a heart that is, or a beat in an arrhythmia?
We have not knowingly done that for a couple of reasons. One, of course, it's a little bit problematic from an ethical standard to record people when you know that they're not well. But, you know, it's a very interesting question because, of course, the professor had a heart condition, and that's what ultimately led to his passing. And what was interesting about this is, you know, he and I, we had discussions, all of us had discussions about the fact that in some way, the work that he'd been doing all of his life led up to him understanding the condition that he was suffering from, the heart condition that he was suffering from. So the question is, did he capture that in any of these recordings? I don't know. So that's, when you ask me, I say, we haven't knowingly done that, but the professor may have.
Thank you.
Yeah, I was curious, his research had shed light on mental health and like
It did, and you know, I can't remember what word he used. It wasn't really ironic, but it was, you know, he was acutely aware of the fact that, you know, he was stricken by this condition after studying this for all those years. He was acutely aware of that connection.
I remember him saying something like, the whole universe prepared me for this, or something to that effect. Because it's true, his whole life's work kind of illuminated his condition. He understood it better than the doctors, I'm sure.
Are you trying to affect your own heart rhythm?
Not necessarily knowingly. At least for me, my best playing happens when I'm not thinking at all, or there's no thoughts happening. It's just...
Are you sensing your own heart rhythm when you play?
So there's a general question and a specific question in there. So some researchers have looked at this in a more general way. So when you play music, you create a whole range of emotions. And the question is, do musicians sort of experience those emotions when they're creating them? And the literature suggests that that's probably not the case. That, you know, the act of producing the music itself puts some physiological constraints on what the body itself can experience. On the other hand, you know, as the professor had said, you know, the universe was preparing him for all this. The universe has prepared us to play at any given moment. And that's being expressed, at least for me. You know, the sum total. You know, you can think of your life as like a ball in a room that's being bounced around. And at any particular moment, it's the sum total of all the bouncing that has taken place in your whole life. And that's, to me, what it's like when I'm playing. It's, my whole life is there. Scott, I don't know if you want to comment on that.
Nobody's asking me any questions. They all want to know what you have to say.
No, I was asking you too. I was asking you too.
What was the question again?
Are you aware of your heartbeat changing when you're playing?
Yeah, no.
Do you think that when you're in a receptive mode, not playing, it's possible to feel the release or constriction in your vagus nerve?
I'm not knowledgeable about, I've never been to Vegas, so I'm not knowledgeable about that. Your first question about the heart, the only time I'm aware of what's going on with my heart usually is if I've been playing really hard and I'm almost out of breath and I've really, and then I stop and then I feel my heart going boom, 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 and I'm breathing like this, So I'm aware of that. That's more in the interstices of the music than in the music itself. But, I find it, I'll just chatter here for a second. I find the whole thing fascinating about the heart rate variability thing, which Jules introduced me before Professor Graves did. I was not aware of this idea that your heartbeat is not really supposed to be completely steady and regular. I thought boom, 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 and if it's going boom, 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 something's wrong. And so Jules kind of hit me to the fact that it's kind of the reverse. And he said, a matter of fact, very low heart rate variability, meaning very steady pulse, is a pretty sure predictor of illness. And I thought about that a lot. I thought, wow, maybe there's a reason why I'm drawn to certain music. Because, right away I connect everything with music and with nature. And I thought, it always bothered me my whole life how most popular music goes bang, 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 over and over and over and over. Absolutely steady, bang, 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 And I used to complain about that. Why does music go bang, bang, bang all the time? And people say, God, come on, that's the heartbeat. That's like your heartbeat. That's based on your heartbeat. I go, I don't know, is my heart doing that? Come to find out it isn't, And so I started thinking, okay, maybe certain music is actually healthier for you, we play music, this is free improvisation, what we're doing now, but I'm a jazz musician, so I play all kinds of, old tunes and swinging and ballads and all of that, and it's never just bang, bang, bang. There's always this push-pull in the rhythm. That's what we call swing. It's a variability in the time, within the beat, within the measure, within the phrase. Variabilities within larger variabilities, and that's part of what makes the music just kind of move in a certain way that it's not what I call the pile driver, It's more of a dance. It kind of takes you and says, come on, let's go over here, And it's a very different feeling than just being driven by this pile driver. So I find the whole thing really fascinating. And then when I started getting involved with Milford Graves, and I realized he's all up into all of this, like way up into all of this, and has really studied it and everything. And I think, was it the time I took you, I think it was, the time I took you to meet him at the Jamaica Center for Learning, what's it called? Center for Arts and Learning, or something like that, yeah. And so there you, and he was already ill and everything, but he did this kind of lecture demonstration, and it was spellbinding. And it went on, and he's telling all these old stories and all this stuff, and he's talking about when he played timbales in the Latin bands, and pop, 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 and he starts demonstrating all these rhythms and everything. And then at one point, he started talking about the heart rate thing, and he started playing certain rhythms that we're all used to hearing and stuff like that. And he's talking the whole time, So when I was young, and we would go, and then I started thinking, well, what if you change it up? What if you introduce this variability into it? And he starts it's like combining two signals and creating a new wave. He created this new waveform out of this stuff, and that for me was really amazing because you could see and hear the results of introducing this kind of variability into these steady rhythms and what that does and what that creates. And he really created a sound with that. Nobody played like him. He had his own thing. I'll shut up. Milford Graves, everybody.
Yeah.
I remember what he said about you too. Like we gave him an album, and he checked it out, and he said, "Yeah, that's really nice. You know, that's really good." But I'm gonna change your thing up. Do you remember that?
Yeah. Yes.
A two-part question. Is there any studies done on heartbeats or any physiological response in an orchestra as they're playing together? Is there, do they start to coalesce in any physiological way? And the second part of the question is there any studies how the audience hears the orchestra or a jazz group, a group?
Mm-hmm. So the answer is yes. There's a woman, I think she's in London now, Elaine Chow, who has studied this. And some of the, what Scott alluded to, we published a paper, it was in Scientific American last year, a group of us that included some of the insights from Professor Graves. But she has actually studied, she's wired up orchestras, studied them, and also the audiences. So Elaine Chow, C-H-O-W.
Was there a positive connection?
Oh yes, absolutely. Absolutely.
I'm curious how other drummers in that kind of era were receiving the way that Milford was approaching this, I guess rubato approach, trying like palm motion, like Milford Graves or like Ed Blackwell or something.
Oh, that's an interesting question. Professor Graves, of course, knew all of those people and had a lot of connections with them. But to give you an example, when we were at this Jamaica Center for Art and Learning, and Professor Graves was giving this lecture demonstration, Roy Haynes was in the audience. So that just gives you a clue. Yeah. Roy Haynes was in the audience, checking out Professor Graves. Yeah. So I know that we're out of time, but we're going to just do one very quick little piece for you to close the night.